All right, so we are going to be looking at distributive property or the distributive law, right? If you say law or property, distributive law or distributive property, it means the same thing, right? So you might see different questions with different terms in terms of me moving from distributive property to distributive law. So I'll be going between both of them so you can understand that it's basically the same thing. All right. And this down here, no, I don't want you to get confused with this. I'm going to explain this into detail so you can understand. All right. So don't let that scare you. By the end of this lesson, you should be well on your way to understanding exactly what this means. I'm going to make it so simple for you that you'll definitely understand it. All right. I want us to solve this puzzle right here now. I want you to give me different letters and I'll fill out the boxes and then we'll see the word that we come up with. All right. So you can unmute your mics and give me some different letters for me.
D.
B. B as in boy.
No, sir. D.
Oh,
D as in dog.
Okay, D as in dog. All right. So let me put D. Anybody else?
E, sir.
After you go and somebody go, you can guess again. Who again?
I.
Who again?
S. T.
No.
R.
Let's see. Listen now, let me grab this. You might feel so you're smart with that one here, but me I go catch you with that one here, man.
R, sir.
T. Barrett, where you did camera, where you did see again? I? Alright, do you have a next I over here, sir?
R.
V.
You have the R.
I. I.
We have the I already. One more I there, sir, again.
B.
B.
Yes, sir.
Alright, you feel bright, not true. Go on.
U.
You, go again.
Yes. V again, sir.
Okay, but tell us you feel bright, not true. Well, it's not V. Because I know V.
O-N.
What that?
O-N.
O-N. Good. You see Campbell? Me know what Campbell is gonna say now. O and N, not true. Good. What Campbell basically was doing was to try and spell out the word distributive, right? And that was all over the front page right here, so that's what you were doing, Kadeen. But we kind of change course and we're gonna look at the word distribution, right? So that's basically what we're gonna look at first before we move into the other concept. All right, so let's put our and who gave me the two last letters? These letters.
Me, sir.
That's who? Fraser?
Yes, sir.
All right, that's very, very good. All right, next thing. So our word right here is, all right, let me put in our word, is distribution. Let's look at that first. All right. That's the word that we are going to be looking at before we move on. Now, when I hear the word distribution, what comes to mind? This question is for everybody. So distribution, what comes to mind?
Handout.
All right, very good. Let's put that in. Let me get my pen tool. So we say handout, right? You can give me some more clarity on that. What do you mean by handout? When you say handout, what do you mean? What do you mean? Anybody can answer that. Come on, guys. When you say a handout, what do you do? When you hand out something, what do you do? What action are you performing when you hand out something?
So like you're giving out some papers or things, sir.
All right, good, very good. So when you hand out something, you're actually giving out something. All right. So let me just put giving out something. And you say pens, like you're giving out pens or papers. All right, good. So which other word comes to mind whenever you think of distribution or handout or giving out? Which other word you can think about that would describe these actions? Come on, think, man. It's kind of early, but just put on your thinking caps and think about what we're doing. So which other word or phrase or term could you use to describe this action, handout or giving out? Which other word you could use to describe that? Fraser, put on your cap and make we hear what I go on. Campbell, same thing, everybody. Come. Come, which other word you think of when you think about when you're handing out something? What are you doing? Now share something. Not true. You're sharing as well, right? Alright, let me just stick a pin right here so now. For me to be going on, say for example, 5 minutes or less, and I'm not getting any response from anybody, I go just assume say I'm me alone upon it, and everybody gonna do what they have to do. And I'm me alone actually on the system here. Alright, so we need to give our responses and make we know what really take place. Hold on. What are you getting from this formula right here? Anybody? Based on what we have went through in this stage of the explanation, what are you understanding? Let me check on something. That's the map. Right. Fraser, wake up, man. What are you understanding from this formula right here? So let me rewrite it. A, B plus C. Alright. Based on the explanation right here, teacher issues the paper to hands a paper to each student. In this case, consider the A as being the teacher, right? And consider the B and the C as being students, right? And if this is the case, the teacher would have to hand a paper to each student, right? Teacher to B, then teacher to C. So he has to go to each student. So this would be equal to Fraser. What would this be equal to? Fraser, Campbell, Powell, and Blake. What would this be equal to? So teacher A to student B and teacher A to student C. What would I have here? So we're getting more mathematical now with the explanation. What would I have here?
A times C.
Remember, we're doing it in order now. What would I have here? Come now, which one we're doing? Which student is in there? Which student to pass first? Reach first. Student B or student C?
B.
B, right. So what would I have here now?
B times A.
All right, you can say B times A, or you can also say A times B, right? So let's put A times B. Now, what else would we have?
A times C plus A times C.
All right, plus. We use plus because we're already adding at the top, so we use plus A times C. And we use multiplication because the distributive property is basically relating to multiplication. As it states, the distributive property of multiplication right here. So Fraser, what are you getting from this, Fraser? Fraser, unmute your mic now and talk to me. Let me check who is here. Fraser, what are you understanding from this now? So we had the A on the outside. So the A is like the teacher, and B and C are like the students. Remember, the teacher went to each student and hand out the test. So he went to B and then he went to C. He went to C. So this now gives us A times B because A went to B first and then A times C. It went to C afterwards. So that basically explains this, as in A, B plus C is equal to A times B plus A times C. So that is where that actually comes from. And it further states that the distributive property also works with variables. We'll cover the variables or numbers separated by subtraction or addition sign. So we can use it for variables as in X, H, Y, M, and all the other letters. And we can use it for just numbers. All right. So I'm going to do a few examples and then I will give you some to do as well and share your responses. So it's gonna be super easy. I try to make it as very basic as possible so you can get it. Let me recheck to see who is here. Anybody having any issue seeing the screen or hearing my audio, please indicate. Let me know if you're still in so I can start the explanation. Everybody seeing the screen? Everybody seeing everything here?
Yes, sir. Yes, sir. Yes, sir.
All right, good. Sound like everybody, all right? But this case now, I might be going between, like, or back and forth between the classroom page and this page. All right. I can just sketch it right here. So teacher, right there with the papers, students in the classroom. Right? So in this case, for this first example, you can look at the 2 as the teacher and the 1 and the 3 as the student. So the teacher would have to go to student, to go to the first student, which would be, mathematically, this is 2 times 1 and then 2 times 3. So this would be equal to, let me explain this first, 2 times 1 plus 2 times 3. And I want to point out something important, very important. If you see I use the word expand, right? This expand right here, so I am only asking you for the expansion form. I am only asking you for this form right here. Please mute your mic while you're listening. Check your mic. Right. So now I ask you to expand. Like in this case, I only need you to give me this, because I structure 2 different types of questions where you will have to expand, then also calculate a value, which I would be going into further down in the lesson. So if I ask you to expand, what does expand mean? If you expand something, what does that mean? If you it doesn't have to be in maths, you know. If you expand it, what does it mean, Powell?
Explain something.
Not really, not exactly to explain. What does it mean? Anybody else?
Makes
Hmm? Expand, explain, or probably in some sense, probably you could provide more. All right, you could provide more explanation in that case. If you explain something and you provide more explanation, that's basically adding more volume or actually expanding what you have already given. So good. To some degree, expand can also mean to explain, give further information, expand on what you have written or expound. But once you add more volume or more quantity, it's a means of expanding. Fraser, you were gonna say something. What does it mean to expand?
make some larger, sir.
Good. So you make something larger, make something bigger, increase the size. So right here, when I ask you to expand the following, you just need to, just carry out the distributive property, do the expansion, so you have a larger expression like that we have right here, right? Over this side. Very bigger than that one. So this would be where you stop. That would be your answer when I ask you to expand. Understand? All right. Next one now. While I'm carrying this out, you can ask any question, but I'm gonna work all these examples and then I give you yours to carry out in class right now. All right. What would I have right here? All right, what would act as the teacher in this case, in this question? Based on the
Tree, sir.
All right, based on the example that we did, let me clean this page off a bit. So based on this scenario, the teacher handing out the papers. All right, look at this. Do you realize how this kind of looks similar to what we're doing? All right, look at this. So for example, I have 2, 4 plus 5. The teacher is standing by himself, right? Look at this now. Suppose you had done something like this. You see that? It looks kind of similar to what we have at the top mathematically. So you can consider the students as the elements that are in the bracket. Just like how we have this up here. So when you think of this, just think back on the students who are in their own group, and then the teacher right here would be the 2 on the outside. Understand?
Yes, sir.
Fraser, Powell, no, and Campbell, Blake.
Sure.
All right, good. Understand?
Yes, sir.
All right.
Yes, sir.
So
Sir.
good. So in this case now, Blake, how many students would we have in this case? Right here, so for this example. What?
5.
Hold on there. I want Blake to give me what elements or what in this expression would you classify as being the students? So we have 3 and we have 5 and we have 4. Huh?
So the one in the bracket, sir.
Right, the one good. These in the bracket. All right, as always say, student in our bracket. These in the bracket would refer to them as the student based on our scenario, and the 3 would be the what?
The teacher.
Good. So right. So in this case now, the teacher has to go to each student. Right. 1, 2. Good. So what would I have here now?
3 times
3 multiplied by 5.
Very good. And then
minus 3 times 4.
3 times 4. And as I said, whenever I ask you to expand, Just leave it right here. That is your answer. Just expand it. Don't do anything else to it because I want you to get the difference between the expansion and also finding the value. All right, so moving on to number 3. Blake, what is the teacher in this case?
7.
Very good. All right. Fraser, how many students you have? Fraser?
1 and 2.
The name Fraser, you know, man. You change the name. So, if I ask
No, me not here.
if I ask you how many students we have, you know, I don't want you to add 2 plus 1. I just want you to, this would be 1, this would be 2, so we have 2 students in this case. All right. So, what would I have here?
7 times 2
7 times 2
plus
Plus
7
7
times 1.
times 1.
7 times.
All right, good. 7 times 1. And that is where you leave it. You only expand it. You make it bigger. You leave it right there, so we don't go any further. That is the answer. And that would be your 1 mark. Number 4 now. So we're getting the hang of what is happening. We're understanding how this is being performed.
Yes, sir. Yes, sir.
All right.
Yes, sir.
Good. Fraser, how many students you have right here?
2 and 5.
All right, 2 and 5. That means we have 2 students. 1, 2. Remember? Just like in the bracket right here, so with the explanation, we have 2 students. Campbell, what would be the teacher right here, Campbell?
4, sir.
4. Good. So what would I have for this part now?
4 times 5
4 times 5.
plus.
Check again. 4 times 5.
No,
Take away.
Thank you. Take away
and 4 times 2.
4 times 2. And that is where we stop with that. 4 times 2.
I need it. I need to make.
Okay. All right. So, what difference can you identify? All right. What is the difference between these 2 expressions? If I have a, hold on. Wait, hold on. Let me give it correctly. If I have a, b plus c, and I also have b plus c, a. What is the difference between those 2? Apart from the color. Apart from the color difference, what is the difference between the 2 expressions?
The first one, the A is at the front, and the second one, the A is at the back.
All right, very good. Good observation. Everybody else can see that?
Yes, sir.
Right.
Yes, sir.
Good. So I want to point this out. You would have some questions. For example, for the first example, I have 2 is at the front, and also number 2, 3 is at the front. But if you notice for number 3 and number 4, 7 is at the back, or 7 comes second, and then for this one, 4 comes second. It's the same procedure, right? Because if I say, all right, give me the answers for this now. 2 times 1 and 1 times 2. What would I get for this?
2.
2. What would I get for this one?
2.
2. You realize that the 2 was at the front right here, so not true. And the 2
Yes,
down, the 2 there right here, so second. So it doesn't matter where the 2 is. In this case, we get the same answer. And that's a concept that we will explore. I think that's a concept that we will explore further down in our class. So when you have, so whenever you see something like this with the number that comes second, don't get nervous or confused. It's the same procedure. So you have any questions about this page? Anything you want me to clear up before I give you your activity? It's coming right after this slide.
No, sir. No, sir.
All right, good. All right, so everybody, I want you to head up your book, ensure that you have your date, question, and just carry out these solutions for me. I want you to work them right now so that we can record the answers on screen and then we move on. So start working these now for me, everybody. I'm giving you what we need. You don't need more than 5 minutes. 5 minutes. 5 minutes, good.
Yes, sir.
All right, just right. So as the question say, expand using the distributive property, the distributive law. So start right now so we can get the responses then. All right, so we finished the activity, everybody. I heard from 3 persons. Everybody finished?
Yes, sir.
All right, good. No, all right. So four of you are on currently. Powell, talk to me now.
Yes, sir.
Let's go. So let's go to number 1. This one is for Siobhan, Mackay. This man, why you join the class 10 o'clock when class over, Bridget? Right, it's now 10 o'clock.
Just a wake up.
But I mean, you just wake up, man. Class starts from 8:30, Bridget. And yeah, start the class 10 o'clock when
That
class.
is to work last time.
Yeah, man, but you have to ensure so you take some responsibility for your class, Bridget, because class important to you, man. You come on when the class actually finished, but nevertheless, still, I go make preparations so you get some stuff. All right, so let's go over here now. So, how many did say Powell?
Yes, sir.
Yes, man. This
Yes,
one,
sir.
yeah, this one is for you. So, Powell, if we're just expanding this, Powell number 1, what would be the teacher in this case? Powell, question.
7, sir.
7 is the teacher. What elements would represent the students?
The 4 and the 1.
Ah, good. So what would I have here for my answer?
7 times 4
7 times 4 would
plus 7 times 1.
7 times 1. Excellent. That's basically where we stop. You can just put a tick beside that in your book here.
Yes, sir.
I give you some other work so you can submit and I mark them personally. All right, so that's for number 1. Blake, number 2 for you. Right.
6.
Hold on there. Hold on. What would be the teacher? This is number 2 here, someone. That's a 3. What would be the teacher in this case? What represents the teacher?
0.
All right, 0. Good. So what would we, and what represent the students?
The 7 and the 2.
All right, good. So what would I have right here now for the answer? What
0 multiplied by 7.
All right, 0 multiplied by 7 minus.
Take out.
Sorry, go on.
0 multiplied by 2.
All right, 0 times 2, and that is your answer. Remember, don't go ahead and carry out the calculation. We just need the expansion. We need to wrap our head around the expansion example first before we start do any calculation. I'm going to give you that in the next class. All right, so this is Powell, this is Blake. Fraser, number 3. Fraser, number 3.
Sir,
Yes, you're number 3. So what would be the teacher in this case?
6 multiplied by 10, sir.
Hold on. What would be the teacher? What would represent the teacher?
That can
6, sir.
6. And what represent the students?
10 and 5.
10 and 5?
6 multiplied.
So this would be what?
6 multiplied by 10, sir.
Right?
Minus 6 multiplied by 5.
6 multiplied by 5. And since we are just dealing with expansion, we just make this bigger. That's what we have. All right, next person, Campbell. Are you next?
Yes, sir.
All right, yeah, man. This one is for you. What represents the teacher in this case?
3, sir.
3. What represents the students?
In 9 and 4.
Very good. So, what would be our answer?
Alright, 3 times 9, sir.
Good. 3 times 9
Plus
plus
3 times 4.
3 times 4. All right, excellent. So, you realize I don't really nothing hard way to still, but if you pay attention and apply yourself, then you will understand what is happening. All right. So I think it's not the end of the class, but I'm gonna put together an additional activity on these and send it in the WhatsApp group so you guys can do some further practice, right? And what I will do, I'm actually recording this, so I'm going to also upload it to YouTube so you can watch it. So you can go back there and rewatch all that we have covered in this lesson. Right, everybody? Good?
Yes, sir. So, sir, when you send you want them in the WhatsApp group, okay? Do them and send it back to you, sir?
Yeah, man. The more you do, the more practice you get. No, just do them and send them. All right, Makai. Siobhan. All right, going back in bed. All right, so I'm gonna end this lesson now, so you can move on to your next class. I'm gonna send the YouTube link for this video when I upload it. All right.
Okay, sir.
All right. Have a nice day. Have a nice day.
Same to you.